So my name is Zahid Ilkal. I work with CommVault for the CommVault product management team. In this section over here, we're going to be talking about the end-to-end data protection strategies that CommVault employs in both VMware and Hyper-V environments over here. So quick overview of what we do from a virtual machine protection perspective. So our agent is called Virtual Server Agent. You'll see VSA being used a lot, but basically this basically is a slide that checks it off. It's agentless, so you don't have to install any software in the virtual machines. Whether they are running applications or not, we can protect them in an application consistent manner by sitting outside and then using, in the context of VMware, using vStorage API, and in Hyper-V use the VSS framework over there to capture the consistent copies. It's extremely scalable, so you start off with a 20, 30, 50 VM environment on a single Windows box, but literally when you size our nodes properly based on the specs over there, you can drive around 30 terabytes of VM data using a single node. And there is this one configuration we call 4x2 grid, which basically takes advantage of our scalable partition deduplication options, and essentially a 4-node grid can drive protection for about 120 terabytes worth of virtual machine data. That could be 50 VMs, that could be 2000 VMs, doesn't really matter. We really care more about the size of the allocated data, not more than anything else, right? And that includes the 4x2 grid includes things like load balancing and resiliency. So if one node in the grid fails, it automatically fails over to the other thing over there. So it's not just resilient in terms of the infrastructure, it's also resilient in terms of the backend storage. So if one of those backup mount paths, or what we call disk repositories, go offline, we automatically fail it over to the other one over there, and so on and so forth. And if everything is online, then we make sure we load balancing across the board, on the storage, on the backup servers, across ESX servers, and across data stores as well. So there is load balancing built in at each individual element on this one over there. We talked about global deduplication. It's not just it's not deduplication at the job level or the VM level. It's truly global deduplication across wide variety of VMs. You could potentially have a grid that is doing a single dedupe pool for all of your VM infrastructure, and it will all deduplicate against each other. It doesn't have to be VMs created from the same templates and so on and so forth. It could be a wide variety of VMs out there. And the last thing one over here, which is big focus for us, is basically it's not just about how we capture information, it's about how do I make it multi-tenant and aware to individual stakeholders, so that IT is no longer the undeletes department, so that IT goes in and empowers their end users to manage their own servers, goes from being able to recover their own files to recovering entire virtual machines without exposing the entire VMware infrastructure, to being able to do things like creating their own VMs, provisioning their own VMs, creating software snapshots for their own VMs, and so on and so forth, without ever having to go into vCenter or into the admin console on Hyper-V. So we can talk a lot about additional individual features in the software and stuff like that, but what I like to usually do is I approach it from what does a customer environment really look like. So when you really go into an environment, yes, they are heavily virtualized and stuff like that, but there is still a significant portion of physical servers out there, especially those that are running tier 1 apps out there, applications or web servers or whatever. Some of them still are required to be physical. When you go into the virtualized environments over there, not all VMs are created equal. Just like in the physical world, not all VMs do the same workload. All VMs have separate I/O requirements, separate workloads, separate applications running in them. I would say if you look at the majority of the environments, this tier over here, which is running your mission critical application, it's about 10 to 15% of the VMs in your environment. Probably about 30 to 40% of the data is in those 10 to 15% of the VMs over there. Silver VMs are those low transaction, low activity applications, or your tier 2 apps that are not as resource intensive or IO intensive. And then of course these are your bronze class VMs. So when we go into these environments, we always like customers to start thinking of their environments in these terms, because when you do break up your environment in this terms, then you're going back and saying, all right, when I think about my recovery objectives, I need to design for recovery objectives, not for all 2000 VMs over there. Really, I need to think about what my recovery objective looks like for this, and this, and then I can plan my recovery requirements accordingly, right? So then I can go back and say, I don't need to do hardware snapshots across all of my VMs. I just need to do it for these set of VMs over here, because they're the ones that need multiple recovery points a day. Those are the ones I need to bring up quickly. These ones, yes, I still need to efficiently back them every day, but they don't need to come up as often.
Do you have not just pure VM backups, but do you also back up vApps in a consistent state among the, so if you had like an n-tier app where it had front end and back ends, then you could restore the app as a body or?
Right, so the current the version over there, currently it doesn't restore all 3 VMs as a vApp, but when we talk about things like workflow, there's an orchestration engine that we have in the middle, over there, which will essentially kind of achieve the same thing.
Is it natively aware that it's a vApp, or is it something that we program in how we apply policies?
When we capture it, we actually capture the vApp, and when we actually capture the vApp metadata as well, especially in the vCloud context there. So when we bring it back, if I recover it back into vCloud director, it will bring back, if the vApp already exists, it will bring it back into that vApp context.
Its own space.
And if I take all of those, it will bring it back there too. If the vApp doesn't exist, that's where we have to kind of orchestrate a little bit on top there. All right. So one of the things that I usually like to start off with is when people say, yes, VADP is great, especially in the VM context. VADP is great for all of the VMs out there, and once you have VADP and once you have change block tracking, you really are all set, because your backups are really fast and you really have no impact. And I always go back to this and say, you know what, that's true, but go back to the previous slide where not all VMs are created equal. That means the same data protection strategy doesn't apply equally to all VMs. You really need to think about, when I go in and pause or quiesce that VM for backup, what is the impact of that activity on the production workload? So here's an example, and this is based on real tests that we did in the lab over there. Here's an example of a virtual machine which is not very big, but which has a little bit of, which is high IO activity on the system over there. And there's another VM which is basically low activity. Now we all know this, when I go in to do a VSA based or VADP based backup, especially in the VMware context, same thing applies in the Hyper-V context, by the way, just VSS instead of VADP. When we go in to back up the VM, the first thing you have to do is you have to quiesce the VM, because when I'm going to read data from the VMDK off, I don't want anybody else writing to it, so we go ahead and quiesce it. When we quiesce it, VMware is going to go create a redo log file, and then all of the changes that occur on that VM are going to get written to this VADP in this redo log file over here, right? So that quiesce process probably doesn't take too long, maybe 30 seconds or so, maybe a minute, for most cases. But now VADP, and this is how most solutions go in there, they're basically going there, this disk is frozen, so let me go in and pull all of the change blocks from here down to here, this over here. Right? And this process, if that virtual machine is 100 gig or 200 or even a 500 gig VM, that process is going to take a good 15-20 minutes or 30 minutes, even with change block tracking. I'll talk about that in a second. So while I'm doing that move over here, this VM has stayed in the quiesce state for that long, and all of the changes that were happening on that high transaction VM are getting written in this redo log file, and my redo log file keeps growing and growing and growing. If I'm a low impact VM, then the redo log file is not that big. Let's say it takes me about 30 minutes to create a backup copy. My VM has been quiesced for 30 minutes. I'm done with my backup. Then I go in and say, all right, VMware, go and delete the snapshot, unquiesce the virtual machine. What does VMware do when I say unquiesce it? It needs to take everything that's written in the redo log file, freeze activity on this, freeze activity on this, even for the application, start replaying everything back down, right? This is where you start seeing things like clusters failing over, snapshots hanging around, you're not being able to ping to the VMs, not being able to connect to the VMs. Why? Because VMware has to basically manage this whole redo log process very, very carefully, so that while it is doing this over here, nobody else is messing up with the VMDK. So it has to do a lot of exclusive SCSI logs and so on and so forth to the VMDK. That's where you see all of those issues occurring around. And what's the workaround to this? There really isn't. Because you have to get a consistent backup, you have to quiesce the VM, you don't want to get a crash consistent image. That means you have to do a redo log over here, and then you have to basically do that. So effectively, we've seen this in tests. If it took me 30 minutes to back up, and if that VM was quiesced for 30 minutes, it will take me 30 minutes to replay the redo logs. This happens all very simple to do. Go to vCenter, run IO meter in your VM workload, go to vCenter, right click, create a snapshot, keep the snapshot around for a minute, delete it. it goes right back. Same machine, keep the vCenter keep the IO meter going, create a snapshot on the VM, keep that snapshot hanging around for 15 minutes, and then delete the snapshot. See how long it takes you to delete the snapshot, at least 15 minutes.
But you are slightly oversimplifying, because the delete of the initial snapshot isn't the pause of the VM. The consolidation helper snapshot goes on, the initial snap is deleted, and the pause of the VMs for the commit of the helper
Correct,
snapshot.
yeah. So, right, I did oversimplify this, but the fundamental is basically the same, which is basically the redo log mode.
Up with the impression that the VM is paused for up to 30 minutes.
No, the VM is not paused, because all the changes are actually getting into the consolidated helper. So the VM activity is going on, and that's why the redo log file becomes so big, because the VM is still doing activity over there, right? So now, the only way to basically get around it, the fundamental problem here is my redo log grew this big because I was in a quiesced state for 30 minutes. Now flip it around and say, what if I change the order a little bit? What if I go in and say the same environment, same machine, I go in and I quiesce the virtual machine, right? Which basically creates a redo log. That takes the same amount of time, but then I go in and instead of doing VADP streaming of that entire VMDK, I go talk to the storage controller over there up front and basically say, go execute a very quick hardware snapshot of the storage volume. That literally takes 15-30 seconds and so on and so forth. Controller comes back, says snapshot is ready. I have no use for the VM in a quiesced state anymore because I have a consistent snapshot copy. I let the VM go. So the VM was quiesced for only 30 seconds to a minute. The amount of changes that accumulated in the redo logs are very, very small. Playback of the redo logs becomes very, very small as well. And then I can go back in. I still need to create a backup copy though. A snapshot is just a snapshot. It's not a copy. I can go back in, mount this snapshot to a proxy server or to the existing ESX server as a temporary VM, and then use VADP to grab all the blocks out of it. So basically by just switching the order, I've taken care of these high transaction VMs across the board without actually compromising on RPUs and RTOs. Now the other thing over here is because VMs are impacted for very short periods of time, I don't have to limit myself to nightly backups. Those critical VMs are the ones that require the most recovery points or the most lowest or the smallest recovery points. But those are precisely the VMs that if I'm only using VADP, I cannot back them up more than maybe once a day. Because if I do more than once a day, the impact on those VMs is too high. So we kind of solve the whole problem by flipping it around saying, I'm going to keep the VMs quiesced for only a short period of time, and I can do that 4 or 5 times a day because the impact on those VMs is really low. And then once a day or once in the night, I can mount one of those snapshots. Doesn't have to be all the snapshots. Just take one of the snapshots, mount it up on the proxy, and create a backup copy from that snapshot. But while I'm doing this backup copy over here, there is no impact on production servers at all. Right? Now, this thing over here, one, storage agnostic. The 21 arrays that we talked about, I can do this on each one of the storage arrays. So today you set up a VMware environment on a particular vendor of choice. Tomorrow, for whatever reason, you decide to switch it out. From an operations perspective, there is no impact. You basically go in, you do your migration process from storage vendor A to storage vendor B, and then nothing changes on the backup side. You give us credentials for the array and we snap it up.
Are you using the APIs for each one of the storage
Correct.
vendors to do the initial snapshot then?
Yes.
So if there's a new storage vendor that's on the block and they don't have the API for it,
Right.
you wouldn't be able to use it until that's integrated.
Correct. So we have a program called ICP or IntelliSnap Connect program, where pretty much we've opened up it's a callback routine that as long as you follow this criteria over here, you write your APIs following this format over here, it's just, at that point it's a qualification effort. So that's how we are able to limit ourselves not to 1 or 2 vendors but to 21 vendors. We self-certified maybe 5 of those or maybe 7 of those, and everybody else is basically through the ICP program over there. Now, what about change block tracking? The whole thing around there is if I'm doing change block tracking, I don't have to quiesce my VMs for a very long time because I'm only capturing change blocks. Now again, it depends on the type of VM. If your VM is nice and clean and all the blocks are aligned and everything else, yep, that works fine. But guess what? Change block tracking is what? It's a bitmap, right? It's not an identifier for every block that has changed. It basically says, here's my VMDK, and this portion of the disk has changed, and this portion of the disk has changed, and this portion of the disk has changed. It does not actually say which blocks have changed. Now, if it's a high transaction VM over there, a small file change could get scribbled across multiple extents or multiple blocks on the VMDK, which will go on and touch. When I do a CBT check on that, it will come back and say, yes, even though it's this one file or one portion of that file that has changed, it's potentially 5 different blocks on the VMDK that have changed. The other thing about CBT is a fixed bitmap format, which means I forget what it is. It used to be 256, probably it's increased now, but basically 1 bit stands for 1 segment of the disk, and it's always the same size. So if I have a 200 gig disk, that bitmap, each bit represents this portion of the bit for this portion of the disk, and if it is a 1 terabyte disk, that same bitmap represents this portion of the disk. So even if a small change happens over there, I have to pull the entire thing over there from a CBT perspective. So yes, again, CBT works in the smaller VMs, in those nicely aligned VMs, but typically we know this when you have applications running inside the virtual machines. Applications are notorious about not rewriting existing blocks. They actually spread data all over the place on the disk over there, which basically means every time you do changes, transactions or whatever, whole bunch of disks or a whole bunch of blocks from a CBT perspective get affected. So even if I'm doing CBT based incremental backups, it's still going to cause me to read a lot of blocks. We actually did this. This is not even a very large VM. It's an 80 gig VM. We just had iometer running on it, doing random reads and writes on that one over there. VADP full backup took us 57 minutes for that 40 gigs, right? So the impact, and it took me, quiesce was this much, backup was this much. It took me 25 minutes to unquiesce it, to replay all the redo logs. So the total impact was an hour and a half for a 40 gig VM. If I do an IntelliSnap, 30 seconds full and whatever, and then literally a 2-minute impact on the virtual machine before I can go back and let the machine go. If I turn on CBT, same thing though, the quiesce took the same amount of time. Look at how long it took me to pull out the change blocks. 48 minutes. Because of the IO activity on the disk, it was basically going in, even though the activity was small, it was going in and touching every block from a VMDK perspective. Small changes, but it's still staggered across the disk. And then when I do a change block tracking, pretty much all the blocks have to be read. Again, go back there, it's a decent chunk, even for incremental. So yes, incremental forever and everything else works for your smaller, moderate to low activity VMs over there, but as soon as you go into these high transaction VMs, all those rules fall off. Any more questions on this, thoughts?
Do you have a version of this where you use an actual application instead of iometer?
Yeah, you can actually, we've done this on a SQL based, SQL as well. A SQL, and we did this on...
I know it's very application dependent, but iometer doesn't represent any application.
Agreed. So, but it's kind of the worst form of application behavior. So we actually did this on
but that would
Exchange with
like
LoadSim.
An Exchange database would be pretty similar to this, whereas SQL would be quite different.
We did Exchange with LoadSim on this one over here too. And
that'll give you the same numbers.
Yeah. Similar numbers. Not as extreme, of course, because, but in that case,
it's
the
not
VM
evenly distributed across the whole data set the way this is.
Right.
Yeah.
But in that case, the machine was not 40 gigs. It was a larger data store too. So the impact on that was still quite significant because the blocks were spread across. And especially over a period of time when we don't go back and refragment those Exchange databases.
Yeah.
That's when it gets worse, progressively worse and worse and
more
worse.
And more. Small sets of the larger blocks. Yeah.
Right. Exactly right. All right. So going back to our gold, silver, bronze, our recommendation is when you go and try to deploy a data protection solution, first let's classify this. And when you look at a gold tier VMs, that's where you go back in and say, I'm going to take advantage of the snapshot capabilities to minimize the workloads. So that's where we go in, quiesce the application, create a snapshot copy on the primary site. And if you're NetApp, if you're using NetApp from a storage target perspective, whether it is block or NFS, we can actually take advantage of built-in NetApp replication capabilities, SnapMirror and SnapVault, to drive a DR copy in the backend. Right? So we actually go in, and once you set up our policies, we can go in and say, yep, this is the source volume over here. Let me provision an equivalent sized volume on the destination side, start off the SnapMirror pair, sync it up over here in the backend, and as soon as it's done, kind of pause the pair in the back. So all of that is kind of part of the actual data protection policies there.
How do you guys find that you play with or conflict with other, because there's a lot of folks that are still doing hardware layer stuff as well for other reasons. And is there any issue of conflicting snapshots that are running? You've got their hardware snapshots, you've got your snap vaults that are going on as well.
Correct. So specifically in the SRM case, where we haven't found any, because we basically set up our own new relationships. And again, so when we kind of talk to customers about this, when we give this scenario, suddenly you don't have to do SRM for all your VMs, right? You could do SRM for just your very, very high availability VMs over there. So the amount of infrastructure and everything else gets limited there. And then those are your platinum class, where you can't tolerate a single second of downtime. These are more of your gold tiers, where you can go back and I can still tolerate a few minutes of downtime and get this kind of SLAs over there. So they don't conflict at all, as long as there needs to be a little bit of storage planning, because you need to segregate those workloads from a storage perspective too.
Right.
But most people get that. Now, once I have it on this copy, where I can actually do a revert from the snapshot, so I can actually bring back the full VM or the entire data store just by executing a very fast hardware revert, and that brings up all of the VMs that sit on the volume. Or I can basically choose individual VMs or even individual files inside those VMs to be recovered off. So it goes back to our original tying it back to the original philosophy of touch the data once, in this case for 30 seconds, let the hardware drive the snapshot, and then I go back in from the backend copy and start mining the data for a whole bunch of information here in the backend set.
Are you able to run sandbox restores and isolated restores?
Yes. So again,
newbie question, I know.
So when you look at when we talk to the whole workflow automation thing, there is this whole slew of orchestration capabilities that's possible. So it's not just doing a sandbox of one type. I can basically go in and give it different personalities and go back in and run custom scripts and custom workloads and notify people and everything else. I don't have to rely on SnapMirror and SnapVault. If I have storage vendor A here and storage vendor B here, I can go in and basically take advantage of my dedupe optimized WAN accelerated replication and trickle across only the changed blocks to the DR side. Effectively, instead of if the storage array is capable of doing the data transfer, I will always use the storage array to move it. But if the storage array is not capable, if I don't have identical storage on either side, I'll go in and use my own efficient data transfer technique over there. So we are not so hung up about who does the data transfer. As long as it gets there and as long as I have the index and the metadata, I can keep track of where the data is regardless of who moves it. On the silver or the bronze class VMs, that's where we go back and say snapshots are probably excessive, because snapshots are still relatively expensive. You have to have your storage infrastructure, you have to have your storage licenses, and so on and so forth for it, and you need to make sure you have snapshot reserve space. So don't do that for all your VMs, do it for the critical ones, the ones that really benefit from it. For everyone else, you can go back in and do your incremental forever backups. It's not even source side. We take advantage of change block tracking because we don't have the problem of CBT that we have with big VMs. So you can go in, we can do an incremental forever backups, grab the changes only, store it into our dedupe target, use our replication or WAN accelerated deduplication, bring it up over here on the other side, and essentially do the same thing.